For the circuit, I have to find the value of resistance that when connected to terminals A and B will absorb maximum power from the circuit. So we know that load resistance will absorb maximum power when it is equal to the line resistance. So basically here is Thevenin's resistance. So we need to find Thevenin's resistance for the circuit. And also we need to find the maximum power that it will absorb. So in order to do that, we will have to find Thevenin's voltage as well, so that we have the whole circuit. So to find the Thevenin's resistance as seen from here, what I will do, I will connect a resistance. So there is a dependent source here, one independent voltage source and one dependent voltage source. So independent voltage source will be inactive, so that will be short circuited like this, but the dependent source will remain to calculate the resistance as seen from the other side. So I will apply a current source of 1 milliamps. So this is there, 40 kilo ohms, 10k kilo ohms, and then here 1 milliamps resistance is connected. So like that, and this is 120 V naught. Now for this arrangement, V naught will become 0 since there is no source in the primary circuit. In this side there is the current, there will be no flow of current, so V naught will be 0. If V naught is 0, this 120 V naught will also be 0. So our circuit will become something like this. Basically this one short circuited, this one like that, and then this. So this is 1 milliamps, 40 kilo ohms, 10 kilo ohms, here 1 kilo ohms and 3 kilo ohms. So we have a current source here, and the current will be divided between two branches, 40 and then 10. So basically we need to find, in order to find the resistance, we need to find the voltage here, voltage drop here. Once we can find that, we will divide the voltage by the 1 milliamp current and we will get the resistance. So let's say what's the value of the voltage here will be, we can find the equivalent resistance here. These two resistances are coming in parallel, so 40 parallel 10 will be 40 times 10 divided by 40 plus 10, which is 50, so that is 8 kilo ohms. So basically we have a 1 milliampere current source, that is, and one 8 kilo ohms resistance. So the voltage will essentially be 8 times 1 milliamps. 8 kilo ohms times 1 milliamps will give me 8 volts. So 1 is kilo, the resistance, and this one is milli, so multiplication is volts. So that's there. So we can now find the equivalent resistance, which will be 8 divided by 1, 8 volts divided by 1 milliamps, so that will be 8 kilo ohms. So that will be the value of Thevenin's resistance. Now we need to go back to our original circuit, which is this one, and then we need to find the open circuit voltage there, or we can just find the actually we don't need to find Thevenin circuit because we haven't been asked to do that. So we will just find what is the power dissipated by that resistance. So we will just work with this circuit. We have the circuit now, we have the resistance here, 40 kilo ohms, 10 kilo ohms, so that's 120 V naught, that is plus minus V naught, 1 kilo ohms, and then 3 kilo ohms, and that is 8 volts. So V naught here will be 8 divided by, we can apply just voltage divider rule, so 3 plus 1 times 1. This is one resistance and this is another resistance. They are added and then multiplied by the resistance across which we are finding the voltage. So that will be 2 volts. So that's the value of V naught. So this one will now become 240 volts. So we have, I will just draw that part maybe. So 240 volts there. And then I have 10 here, 40 here, and then I have 8 here, 8 kilo ohms, 40 kilo ohms, and then that one is 10 kilo ohms. So we have, of course, the remaining part like that. I'm not putting in the values anymore here. So since I need to find the power dissipated by this one, if I can find the voltage drop across this resistance, that will be fine. The drop will of course be in this direction because the polarity here is like that. So we have 40 and 8, these two in parallel, so we can just combine them because we are just trying to find the voltage for the time being. So 4 combined means just the equivalent, so that's 40 times, they are in parallel, so that will be the value. So 40 times 8 divided by 48, so that will be 20 over 3 ohms, kilo ohms basically. So that's the value of the parallel combination, and this is 240 volts. So the voltage drop here will be, again if we apply voltage divider rule, it will be 20 over 3 plus 10 here, and then times 20 over 3. So if we just do that, it will be 240 and then 50 over 3 here times 20 over 3 basically, so that's 240 over 50 times 3 times 20 over 3, so that's 96 volts. So that's the voltage drop across both the resistances, because that's the voltage drop. So once we have the voltage drop, I can find the power dissipated by this one. That will be P is equal to V square over R. So V square is 96 square and R is of course 8000, because that is in kilo ohms. So we need to find the value in ohms. We have to be very careful here, because the voltage is in volts but the resistance is in kilo ohms, so that has to be in ohms. So like that, and this gives me 1.152 watt. So that is the power dissipated, the maximum power dissipated by a resistance connected to terminal A and B, and the value of the resistance we calculated earlier, 8 kilo ohms, through which we have calculated the power.